This conference will now be recorded.
Hello, I have a great pleasure to welcome you on our next webinar from the DigiFoF webinar series. Today, we'll be covering the topic of AI-based domain-specific assessment service, and you will see how cloud-based services can be used for assessment. My name is Zbigniew Misiak, and I'm your host today. And what is much more important, in a second, you will learn more about participants, and the list of participants is very interesting. But before we do it, I want to ask you to make sure that all your mics are muted. If this is problematic, I can, of course, mute the mic for you, and this way the recording will be of the best possible quality. If you have any questions and the presentation is so interesting that I think you will have questions, please expand the GoToMeeting pane, and there in the chat window you can put your questions, and at the very end we'll have Q&A part where we'll be discussing all the topics that you want to dig deeper. So this is for technical aspects, and as I promised you, now you can see the agenda, and here you will discover the cast, the presenters. Did you see? You are also included. But now let me give floor to Patrick and Wilfried, and they'll show you how does it look like exactly. So Patrick, floor is yours.
So thank you very much. So I'm going to take over now, sharing the screen. So the short agenda for today is we're going to have a short introduction. Then I'm going to present the approach that we are choosing to tackle the problem of domain-specific assessment services. We're going to look at the technology we use to implement an instance of our approach, and then at the end we'll also have a short demonstration. Now, of course, the cast for today's webinar is, well, we have a few important players in this case. We have the service itself that we will be using. My colleague Wilfried Utz is joining us today as well. This here is me, Patrick Burzynski. You can hear me talking. Of course, you are also part of the cast today. So every cast needs a good story, and every good story needs a beginning. And now, in our case, we begin with a case. In this case, we are located in the domain of enterprise architecture, and your IT architecture is composed of a lot of applications, infrastructure element services, everything you can find there. And now there is a change necessary in your IT architecture. This can have different reasons. For example, maybe some licenses change, or a component has reached its end of life, or you have a new project where you have to introduce new elements. And to support the decision making, you have decided to assess the parts of the current IT architecture that you have. So this is the beginning of our story. This is where we are taking, where we are connecting now further with the webinar. And what are our goals today? We want to look at how to realize such an assessment, but we are not going to look at what we are going to realize or why. So we're going to see how to use cloud-based services to perform an assessment. But we're not going to focus on what is enterprise architecture management. We are not going to focus on why you should use cloud-based services. We are not going to tell you who should be asked questions and what questions they should be asked for an assessment. We're not going to tell you what formulas you need to process the data during the assessment. And we are also not going to tell you how to correctly interpret the results at the end. We are focusing on how to realize this. So to realize any system, at first we need an approach on how we're going to tackle the problem. Now, in our case, we want to present an approach that allows you to gather information from users about your design artifacts, and then you can use this information, the data, to assess those design artifacts. So since we are going from a user-centric view in this case, we are starting with users. There's hopefully a lot of them. They have knowledge, they have information, they have data that we actually want to get access to. So we have a first procedure that we're going to have to do is, we call it in this case the data collection, where we gather the data. One example to do this is using a questionnaire. So the users can answer questions and provide us their data. This gives us the data that we can then use in a second procedure, which we call here data enhancement, where we process the information using different functionalities, different functions, and then visualize the result. And from there, other procedures, other processes, other tasks can take over. Some can be human related, some can be performed by humans, some can be performed by computers to actually interpret the results and use these results and make decisions. So when we look now at the data collection procedure, here's an example mockup where we want to collect. So we are first actually showing the user some information about an application. In this case, it's the AI-based domain-specific assessment service. They also see a short description of this application. Here is a number of issues currently loaded that are documented for the project. Here we have an image, and this is actually now where the user starts providing their answers. Below, where we ask the question, is the above architecture design satisfactory for the application? And the user can select one from satisfied to dissatisfied, different options. And we're also asking the user to specify which of the issues that are currently known for this application are the most pressing according to them. Now, if I want to realize such a thing, one possible approach is, we call it the fixed approach. We can just create such a questionnaire manually and send it out to users. However, the problem in this case is that if something changes, for example, if new issues get added about the application to the system, or if issues get actually solved by your programmers, then you also have to change this questionnaire and send it out again. Now, in our opinion, a much nicer approach is a dynamic approach, because in this case, since we are talking about an application, we are talking about software which has been programmed. So we're kind of in the software programming domain. And there we have systems, for example, like GitLab. And we could actually load those this information, this description and the name from the GitLab at the time of showing the questionnaire. We can dynamically load the number of issues that are currently documented for this project. And we could also create dynamically this list of all the issues that are currently documented for this project. So you don't have to always update this questionnaire, but whenever a user decides to fill it out, we get the current data at that point in time. So of course, for this to work, the survey system needs to interact with other systems. Now here we have chosen GitLab. Of course, if you're from a different domain, or if you want to implement it for a different domain, you can also use other services. This is just one that we are using for this example. Now, since we're interacting with other systems, one of the challenges is, of course, that we cannot cover all possible current and future interactions and integrations with those other systems out of the box. So new systems will be implemented in the future. We might want to integrate the questionnaire with them, and we cannot do that yet because we don't know how they look. So how can we keep this dynamic approach easily extensible for future changes in the requirements? Well, our approach in this case is to basically split it into different components. So we have one component that assembles the entire questionnaire. We have another component that can, for example, load data from GitLab. Another component shows the specific image that we want here. Another component asks here a Likert scale type question. And yet another component would load data from GitLab and present it as a selection list. Now, because we want to live in the future and not just in the present, those are not simply components, but cloud-based services. And we want to also use a simple interface so that the entire interaction is not overburdened. If we also look at the second part of the procedure we had presented before, the data enhancement. So here's an example where we would gather the answers that have been provided for our questionnaire. We would enrich the data. In this case, we want to use to add the information about the company that has developed the application. We group the data. aggregate the values, and then want to create a visualization using a candlestick diagram. Now, similarly to the data collection part, how can we keep this easily extensible? And again, our approach is basically to split this process of processing the data into individual steps, and those individual steps are again implemented using cloud-based services. So from this, we get a conceptual architecture that looks, as you can see now. We have, of course, the OMILAB source code repository. We can find the implementation for the application in this case. And here we see the two procedures, the data collection and the data enhancement. And now the data collection is communicating with something we have called here a user entry controller service. So this is the component that assembles the questionnaire. And then we have here individual question services that implement those different questions. On the data enhancement side, we have an analysis controller service. This is kind of like a workflow execution engine that uses enhancement services and visualization services to process the data and create a result. So if you look a bit closer at the two parts for the data collection and the data enhancement later on, what are the concepts? So when we are assuming that we have a user that wants to provide us with some information by answering some questions. They interact with the user entry controller, which creates a questionnaire, which in turn communicates with one or more question services, depending on how the question is structured. Now, for the question services, we are considering three concepts inside of there. We have question types, question instances, and question answers. So what are those three? Basically, question types, we are considering things that are specify how the user interface looks and what answers can be provided, but they are not specific to a domain. So they are domain agnostic. Like examples for such question types are single line questions or multiple choice questions or those selection list question. Yeah. Another part is the question instance. So this is now where the domain actually comes into play, because this is where the actual question is specified. So what question should be asked the user? So we had before, how satisfied is the user with the above described architecture of the application? This is on the question instance level. And then below that, we have the question answer. So this is the actual answer that the user provides for a specific question. Now, something, because we are using cloud-based services in this case, that we are doing is that the data storage is separated. So the user entry controller does not store all the answers, but the question services have to take care of that. And another thing is, because we have question services described as general services with a specific interface, it also doesn't matter on which level you implement them. You can implement them at whatever level is best for the current case. So a lot of the all of the question service we have actually implemented so far on the question type level, so you can use them in any domain. But there can, of course, be cases where implementing a specific question might not be feasible on this type. So instead, you might implement a question service that is just for a specific instance in your domain. Looking at the concept of the data enhancement, this is maybe a bit simpler. Here we again have a user, and they would actually like to see the results of an assessment. So they interact with the analysis controller, and now the analysis controller can connect with different services. We have here like a category that we call data source services. So for example, those are the question services from before, giving us the data, giving us the question answers of the users. But we can also use data sources from somewhere else, like open data services, operational data services, to process all the data. We also have the enhancement services that take care of the processing and enhancing the data. And we also have visualization services, which can create the visualization at the end for the user. So now we have seen a lot of concepts, but we still didn't really get to the part where we are using specific cloud services. So we might have an idea, but we still need to realize it somehow. And this is kind of where the technology comes in. So we have decided on using Amazon AWS cloud services. So this is a marketing blurb by Amazon, where they say Amazon Services is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services from data centers globally. Now, what does it mean? It means that they're providing a lot of categories of services. So if we look at some of them, there are services for analytics, there are services for blockchain, there are services for storage, database services, compute services. So there's different categories. And if you actually look into those categories, so this is just the compute category, we again have a lot of services. So what we actually have to do now is find the services that we can use to realize this conceptual architecture. And we did a very specific implementation, an instance of this conceptual architecture using AWS. And it might look a bit overwhelming now, but this is kind of when we fill out the details for the previous conceptual architecture. So we still have, of course, the source code repository where the parts are deployed on the Amazon AWS infrastructure. And for the data collection service, for the data collection procedure, we have different services. So in this case, now we have an HTML form questionnaire service, which is a user entry controller service. This communicates with individual question services again. And as you can actually see, we're using different services provided by AWS, cloud services. So this here is the API gateway. This is AWS Lambda functions and DynamoDB for storing the data. We use similar structure also for the question services. And what the question service, of course, can also do, there might be the need to use external services. So in the example before, the GitLab is this external service that we are using to get the data from. But of course, this is optional. Not every question needs to use an external service. Like the Likert scale one, we have predefined selections. They don't need the external service. On the data enhancement side, we have here the AWS step function analysis. This has a similar structure again with the API gateway, the Lambda function, and now instead of using the DynamoDB, it uses the step functions provided by AWS. And again, this communicates with different enhancement services and visualization services. Now, what we also want to do is we want to use simple and widespread technologies and formats used for the communication. So like HTTP, JSON, HTML, CSS, etc. This is actually a practical reason, because by using HTML, we do not have to implement a client ourselves. We can just use a normal web browser. And this also allows us to use those services, those assessment services on computers, on mobile devices, etc. And another benefit of using such simple and widespread technologies is, for example, while we have implemented here an instance entirely on AWS, certain services could also be implemented and deployed on different service providers. So of course, there's also Google Cloud. There's, I think, Microsoft Azure, it's called. They also provide cloud services, so you could also use those. If you look a bit deeper into the architecture of a single service, we have here on the left what we're simply calling now a client. This is somebody that's using the service. On one side, it's the user. Further back, it's the user entry controller that uses the question services. And the general structure is that they have an interface to which the connection can be established. In this case, we're using HTTP endpoints. Those invoke Lambda functions. The Lambda functions have implemented the logic of the service, so they decide what should happen, what should be returned, etc. And because we are in the AWS world, those Lambda functions also use other services. So this is kind of where you have to be careful that, for example, every time you want to create a Lambda function, you also have to specify for it a role to be executed as that has certain permissions. This is simply something from the AWS world of cloud services that is necessary. And this is all provided in the identity and access management service part of AWS. Those functions also write logs that we can analyze if our code is working properly, and they also use keys from a key management service, which is used to encrypt certain parts when the functions are deployed to keep them secure. And those Lambda functions also, in some cases, read and write data to the databases, tables, or objects. In this case, DynamoDB, for example, in the question service, in the question services, when the user provides an answer, we have to store it somewhere. So this is here in this data storage, this DynamoDB. Now, of course, not every service needs such a data storage. For example, when we are looking later on enhancement services, which simply perform a calculation, they don't store permanently data. we do not need this component. And of course, depending on how the service is implemented, other AWS services can be used or exchanged or left out or added. So what are the main technologies that we're using in this case, and tools and the concepts? Well, for the execution, we're using, in our instance, something AWS specific, the API gateway for the interface. We're using JavaScript and Python for the programming logic. Different services can, of course, use different assessment services can, of course, use different programming languages because each service is individually deployed. For the data storage, again, we use the AWS specific DynamoDB. And we're also doing this with a RESTful approach in mind. So we want to avoid state-based communication. For the interaction with the users, we're using HTTP together with HTML, CSS, and JavaScript. For the interaction with services, again, we're also using HTTP for the transmission of the data and using JSON or plain text for the messages. For development, we have been using Git, which is also, of course, why this is deployed on a GitLab, and Visual Studio Code to write the code. And for development, we're using Microsoft PowerShell and the AWS command line interface to actually take the code that has been written and deploy it in the AWS cloud. So now comes the fun part. We have now heard a bit about how the approach works, how the architecture looks for the entire thing, and what services we need. And now we're going to have a demonstration where we all get to participate, I hope. So in the demonstration, we have certain assumptions in this case. So to save some time, we are assuming that the needed accounts are created, that the necessary tools are installed and configured, that the relevant services are deployed and available, and that the people are ready. This leaves us with a few steps that we still have to perform to have like the assessment. We have to create the questionnaire. We have to fill out the question a few times so that we have data to process. We have to process the data to get a visualization, and then at the end we have to admire the result. So we're going to use the example presented at the beginning for the data collection. We have a questionnaire, and in this case we are collecting two parts of data: the current amount of issues for the application and the user satisfaction. We know which application is here depicted, so this is also part of the data that we are getting. So we have the user entry controller service HTML form questionnaire that creates the questionnaire, and we're using different question services to realize those question instances. For example, for the first, we use the fetch HTTP JSON data question service. In this case, we are showing a static image, so we have a static image question service, and here we have a Likert scale question service to show this. Now, we do not yet have a question service for the last part, but this can be implemented by the community. So because we have a system that is extendable rather quite easily, because you have to only ensure that a certain interface is present for the services, you can implement the service and deploy it, for example, again on AWS. But in this case, we are not going to use this one question in our data processing. So because it is, of course, a demonstration, now we have to show something. So what I have prepared, oops. So this is now the project as it is available on GitLab to everybody. We have in the examples folder here a part that creates a questionnaire, and we have actually created here described in a JSON structure, the structure of this questionnaire. So now we want to deploy it. And to deploy it, we have some tools available here, which are also again in this example folder. So the first one I'm going to run. Well, I said copy, and why didn't you paste computer? There, it pasted now. So first, since the questionnaire needs question instances inside of it, we are going to create the necessary question instances. Those are described in this structure here. So it says that we want to fetch HTTP JSON data question, and we specify a message which says create. some details. The status should be available, a label for the question so that we still know what it is, and then the details necessary for this question service to work. If you're interested in the what those details all mean, I would kindly refer you to the documentation of the project. We have described everything there, I think, in decent detail that you can understand and use those yourselves. So basically we have here 4 questions. The second one is again also the fetch HTTP JSON data, static image to show the image that the user has to specify whether they are satisfied with it or not, and then the Likert scale where the user can state their satisfaction. So we're using this as input data for this simple tool. We run it. Of course, I forgot, as always, change directory, examples. I have to be in the correct directory to run this thing. Questionnaire, create, and now we can run it. So you can see some blinking. It has finished, it is done now. What this thing has created in this case is here a simple text file, which contains details about the question instances. So each question instance gets an ID, and we are going to need those later. But also for the next step, we need those IDs here locally. Right now, because we're using a tool that's available in the same folder to create now the questionnaire itself. More specifically, a configuration for the questionnaire that can then be loaded through the browser. So for this, we're using the second part, create questionnaire. This uses a few more details like an ID for the questionnaire that we can use it to retrieve it, a label for the questionnaire, and where actually the HTML form questionnaire service is located. So what endpoint this should target. Okay, to execute this, and seems to have been successful. So now we have a questionnaire available. So when I actually go to the website, so this is for our deployment of the HTML questionnaire service. We can see we now have this questionnaire deployed, ready, and it can be filled out. So few easy steps. Of course, we already had the questionnaire prepared. What's next? So we have the questionnaire. We would have to fill out some of the data, but we're going to do this towards the end because I first want to show you something else as well. The example part for the data enhancement. So in this case, we have, similar to the example presented at the beginning, a few steps where we want to gather data from the filled out questionnaires in object-like structure. We want the ID of the application, we want the issue count, and we want the user satisfaction. We want to add information about the company that developed the project for the application. Then we want to split the data into groups based on the user satisfaction of the company, calculate the minimum, maximum, and average for each group. Then we have to do a bit of a transformation so that the data structure fits for what is needed for the candlestick visualization, and then create the candlestick visualization. Now, one of the maybe more interesting parts in this process is adding the information about the company that developed the project. In this case, we are using an RDF graph describing the world. We're showing here a part of it. And more specifically, we're going to use this part of the RDF graph, where we have defined the projects or the applications. So we actually see 2. We have this AI-based domain-specific assessment service, and here we also have a different project that we have been developing in OmiLab to also provide us with some data. So we have also here in this RDF structure the ID of the project, and we also have specified that the project is developed by this company, which is OmiLab. So what we're going to use a very simple rule to add this data, which we have realized using Sparkle. And now this is how the data enhancement kind of looks specified for the AWS step functions. So what we're also adding here in this case is an interface that we can access those step functions through an HTTP endpoint to start executions and get the results. And here on the right side, it is kind of like a workflow where we start at some point, it performs certain steps. So for each of those steps, again, we have enhancement services, different ones where we combine, for example, several answers. We evaluate the RDF graph with the Sparkle. splitting the value into groups, aggregating the values, performing the transformation that is necessary to create the candlestick diagram. And in this case, we're using a Google chart delegate, which then creates on the client side the candlestick visualization. So for this, we also have the code available in the examples AWS step function analysis. We have here this issue satisfaction company. Now this is not entirely ready to deploy because for it to properly work, it needs to have specified where the API endpoints are located. This, of course, can change from deployment to deployment. So my deployed API endpoints are not exactly the same URL as yours. So this has to be filled out. But otherwise, this shows this builds the structure for the state machine that is executed then by AWS to perform the processing. So we already have already created it. Nope. Let me just. So this is maybe a bit of the user interface from the AWS services, where we already have this state machine specified, the candlestick satisfaction for companies. And I'm not going to show the details because there's actually all of the user URLs that we are using. So I don't want them to show up necessarily in the video, but basically it's already deployed here. And now what I can do is we have also in the example folder mockups, we have specified a simple scenario presenter. We basically specify a very simple JSON object, which tells us, okay, what do you want to show to the user and what is the input necessary. I already have that one open here. And we are going to create the candlestick visualization so that you can actually admire the result. But before we do that, oops, actually, let's keep it here. I have to copy a few values because, again, we have now deployed those question instances live. They have specific IDs. I have to check those IDs. So they're actually located in this file. And I have to fill out the blanks that I have here. So this is the second question. This is the Likert scale question. And I basically say, kind of run this scenario where this state machine is executed with this input. It's an asynchronous execution, so it will have to poll regularly if there's an example. We run it. We're loading the results through the power of OmiLab. And because in this case, I'm actually using data from two different questionnaires, the other one I have already filled out a bit, we can get here a candlestick visualization. Now, that this just isn't simply me doing all the work and talking. I would kindly ask all the participants to fill out the questionnaire. I've posted the link in the chat. I'm going to fill it out myself. So I'm going to say I'm indifferent about this. I guess the click didn't register. There's always some minor trouble. Oh, yeah. Sorry, my bad. I'm a bit restrictive when it comes to allowing JavaScript in my browser sometimes. So finally, I've submitted one question result. Thank you very much, Wilfried. So I'm going to give, maybe you can give everybody like another 30 seconds. All right, this should have been enough time. And now we're going to run the analysis again. So same input as before, using the same IDs. Now the analysis is executed and again, a new time, a new. And we can actually see, okay, the results have changed. So now we don't just have the satisfied and the somewhat satisfied, but also the indifferent and dissatisfied. Of course, in this case, because this is a real project that we are using, and I'm not going to create now issues at random just for the showcase. All of those issues are now here found at 10, because that's the current amount that we have. But as you can see, we are getting the latest results when we're running this analysis. So now we have done all the 4 steps. We have also admired the result. Now, where can you get this? Where can you start using this? Where can you get access to this project? Basically on those 2 pages, we have the project page on OmiLab, and there's also the code found at the repository. I'm going to paste both links also in the chat if you're interested. And yeah, that's it from my side for now. Thank you very much. And are there any questions?
Thank you very much. I'll also switch screen to Wilfried because Wilfried wants to also present something. So give me a second. I hope that now the presenter request
Perfect. Thank you, Zbigniew. Thanks.
Currently. You're welcome.
Just to to point our participants towards one direction that I think Patrick mentioned at the very beginning. In the beginning, is that we talk about a specific domain and how the domain influences things. And the main challenge or question here is, how do we describe this domain and what does it how does it impact this service implementation? And here I just wanted to open up quickly the ArduXX.org page. Maybe Patrick, you can also paste the link as you have done for the others in there, because this is from our understanding a platform that allows us to describe this domain specificity and then actually use the outcome of the implementation, the meta model outcome, in a sense that we can adapt the services and have an interpretation of this meta model on service level for the assessment services then as an input. So please feel free to join here as well and join the ArduXX.org community so that we can work together on these domain-specific aspects. Thank you.
Thank you very much. So as we already told at the very beginning, if you have any questions, feel free to put them in the chat and we'll be glad to provide answers. I must say that from my perspective, it was very cool to see that it is something that you can use in any context. So the presentation showed it in the context of enterprise architecture, but obviously what you could do would be to use it in the context of Factory of the Future. So you could use it to analyze and make assessments of elements like, for example, robot technologies being used, or maybe like elements being part of your higher level models, like, for example, some design thinking stuff, or maybe even the models that were prepared using Synth model. So there are many, many options and you can use the assessment mechanism for various contexts. So I'm waiting for questions and I think 2 questions already.
Zbigniew, just to react on your statement, I think the most challenging thing, but I try to see at the end, is that how do we define the context? And how do we define the context and how does it impact the services that we use? Are all these services general or generic or general purpose? What are they reflecting the domain and the context that you have mentioned before? And here I think I would like to invite all participants to join here also to see how can we realize such domain-specific services based on a contextual description through meta models as an example.
Yes, so if you have some ideas.
Now it's time for your questions. Time for your questions, sorry.
Yes, it will be cool. And the questions that I want to ask is, first of all, you have shown us that it is very, very powerful and very flexible. I wonder if somebody is a business user, is it possible to perform such magic without being a developer? So how skilled do you need to be to make use of this assessment service?
Just using the assessment service itself, the question service that are already available. We are trying to keep it simple. At this point in time, it is necessary to kind of at least grasp a bit JSON, which is a very simple format. It shouldn't be too difficult to learn it, simply because it's the main format we use for communication with the services. Of course, in the future, I hope there will be also some work on creating a user interface so that everybody can use it without having to understand JSON. But the important part is to get a grasp of the concepts and to kind of not dissolve, decompose the thing you want to do. So you want a questionnaire, what are the questions, how should you ask them, etc., those things. And I think that this is, of course, depending on the case, more or less difficult. But I think business users should not have much problem with that. And if it comes, however, to extending the thing, you need some programming skills, because we are using mostly, in this case, we have been using Node.js or JavaScript or Python. But simple adaptations can be, for example, done by copying an already available service, the code for the available service, and making adaptations to it. So with a bit of programming skills, it shouldn't also be too difficult to create new services. And of course, there's those deployment scripts available in the project that deploy those services. So again, those for an individual service, this one can be copied, slightly adapted to fit their own service and used.
Thank you very much. And second question,
it should. I think it's maybe the biggest drawback is that we do not have a user interface that generates to this JSON format, but that's about it.
Thank you very much. And second question, how do you see possibilities to use other survey platforms with this tool?
So not directly planned from the beginning to use other survey platforms with this one, but with a bit of creativity, I think it might be possible, for example, to embed other surveys into the own questionnaire here by creating a question services that embeds the other questionnaire. Or the alternative is to use a mix of both. Have a questionnaire that uses this service, also have a different questionnaire maybe that's simpler, use a different platform, and then when you get to the data processing part, you can take data from both of those sources and merge it together and further process it. So because we have been paying attention to kind of really split those two parts, data collection, data enhancement, and just have kind of like services that collect the data, that represent the data in the middle, you can use different ways to collect the data. Like it doesn't also necessarily have to be questionnaires. Like one example might be maybe to use data that is found on Wikipedia, because that's an openly available source for information. So this might also be an option. Or like we have been using in this case also, built it into the questionnaire, the GitLab parts, but we've been using an ontology that also contains additional information that we're using to enrich the data that we already have. So because of the split, when you're focusing on processing the data, where you're getting the data from, it can be, of course, the data collection, how we have implemented it. It can also be other services. But if you want to make it really nice, there can be a service that also integrates the different questionnaire into our data collection user interface.
Right, I would return this question to Zbigniew and ask him to implement it. It's an open source project, so please be my guest, be our guest, contribute to the community. And I think what Patrick mentioned is we can do it in two ways, so that we can consider this survey tool as a data delivery environment, so it just provides additional input. Or we would like to use the power of such survey tools to integrate and embed things, also possible. But as mentioned, everything is open source. Feel free to join, feel free to contribute and implement those services in case you're deemed them essential. The important thing is that we focus on the domain. We focus on a specific domain that we can represent using also input for the assessment services as a starting point. So I think when I think about survey tools, the classical ones, do I like it, do I not like it, happy faces, not happy faces, I'm wondering what is the domain that is in there and what is the intelligence in there. And I think this is one of the distinction points that we have with our implementation here. But again, the invitation for you, Beneath, and for everybody else, please join us and implement new services that have this paradigm in mind, intelligence and domain specificity.
Thank you very much, Wilfried. Thank you very much, Patrick, for interesting presentation. I think I see two more questions, so sorry. Question from Marian. I'm currently working on my meta model using AutoXX. Question 1, how can I integrate or access the service? And second question, can I modify the questionnaire by changing the provided code?
I'll take that, okay? Sorry, Patrick, I can take that one if you like. You want to answer?
You can go ahead. I've been talking a lot already. I need some water.
Yeah, perfect. You correct me if I say something wrong. So for number 2, this is an easy one. Yes, of course, you can modify things. You can update the code. You can create your own instance with the only consideration that we would kindly ask you to provide us with your adaptations also as part of a community effort. Number 1, for the integration, this is exactly what I mentioned before. So how, when you have seen the RDF graph, how do we establish as an RDF representation? And I think this is related to your question, that we represent the domain aspects in the meta model in AutoXX, and we need to transfer that over. So how do we move that one, and what kind of aspects are essential in order to feed the assessment services, the collection ones, but also the enhancement ones with the information that is on meta model level, and then control or have a domain specific logic in there. How this is done? Well, AutoXX is also an open platform. There's open interfaces, and these two systems can, of course, work with each other. So we have the AutoXX web service interface where you can talk to retrieve information on model level, but also on meta model level. There's the RDF export mechanism that is available. So there's a lot of different capabilities in there that can actually support this application scenario you have in mind, Marian. Okay.
Okay, I don't. Marian sends thanks for this answer. Do I see any more questions coming? If you want to ask questions, this is a great opportunity. Going once, going twice, going 3 times. Okay, no more questions. So thank you one more time very much, Wilfried, Patrick, and thanks to all participants of this webinar. It was great to see the interactivity from your side and questions. And I want to invite you for our next webinar in the DigiFoF project. So thanks a lot and have a great day. Bye-bye.
Thank you. Bye.
Bye-bye.
Bye.